You got it?
Let's do it. Yep.
All right, so I guess this is real and it is happening. Um, what we're gonna do, I don't remember what episode this is. I got too many
I
irons in the
think
fire.
13. It's lucky number 13.
That's appropriate. Um, and let's see, the last one didn't happen because Nathaniel was under the weather. Hopefully you're feeling better now.
I am. I'm tip top. My voice is back. I'm ready to talk.
Okay. So we were gonna go over, I took a slice of, now that data collection is over, I took a slice of it and was just running through some operations in R just to test and see how things were working. So we were going to go over that. So I think what I'm going to do is I'm going to share, I'm just going to share R with you. Let me see here. All right, so you're looking at this, right?
Yep.
Okay. So I already kind of pre-did some things here, but right now I'm just looking at the A pool.
And that's the less dense, not as much metadata.
Correct.
Pool, right?
It's much larger. You know, it's over 20,000, but it doesn't have a lot as many covariables. Let me also ask, just as a programming note here, are you still looking at R? Because I've got something pulled up in front of it. What do you see right now?
I see of the thing you've got pulled up in front of our little gray screen.
Oh, it's blocking you from seeing it?
Yeah.
Is it better now?
Yeah.
Okay. All right. So that's how that works. Good to know.
It's back.
Yeah, I know. I moved it back over.
Okay.
I need to look at the notes. So yeah, we're looking at the A pool, and so I was kind of thinking, how are ways to take a look at this data, right? Because we've got those titles and descriptions; those are textual. And right now, my kind of test assumption is just to merge those together, not to treat them separately. Although we could, I don't know. There's a spectrum here in terms of utility, right? Where it's like, what's going to be meaningful versus what's just going to be getting into the weeds of, what's the difference between looking, at the titles versus the descriptions versus just treating them both as text and lumping them together.
Right.
So right now, I put them together. I just essentially merged those columns together, and I'm treating that as the textual data, and then preserved the other columns. So, and I was kind of thinking, in fact, I guess it'd be meaningful if I just sort of share that. I was just kind of thinking, what do we do with this stuff, right? And so one of the things was, we can get a sense of things like just a basic sense of term frequency, right? So if we take all the data of all the different sort of collections here and just put it into a big bag, right? A bag of words kind of thing, we can just pull out some basic measures of frequency. Both just raw, so what's the count of terms in there, but then also weighted in particular ways. A popular one is TF-IDF, where you take the term frequency and the inverse document frequency. So, what that means is if you have a term that appears a lot, that may be useful, but it may not, right? Because something like the, right, a common article, if you don't pull that out through stop words, which I did, but a common term that's spread across all of these different entries, it's meaningful in the sense that, oh, okay, that is something that's being discussed quite a bit in the whole thing, right? You follow me?
Yes.
Okay. I don't know if my speakers are on, but it could also be meaningless. So, something that doesn't get pulled out through stop words would be a good example. If every one of these says, minute, for example, it just might not be a meaningful term because it's like, oh, well, that's going to be in there because it's saying here's how many minutes you have, right?
Right, right,
So a weighting like TF-IDF fixes that because it checks frequency and how many documents is this spread across. And then it weights them. So if it appears in fewer documents, that means, oh, this term is significant to
okay, that
that,
makes
right? So it pulls out, it says the statistical way of pulling out, oh, in this document or in fewer documents, this term pops up, but it doesn't pop up in all of them. So it's meaningful, right? One way to
right,
think of this is, a lot of this is used in stuff like search engines, right? So if you had a term that was on every page and on the web, you couldn't search by it.
right,
But if you had pants, and pants is only cropping up on a subset of those pages, it's like, oh, okay, but there's a lot of mentions of pants.
right.
So you see what I'm getting at here. The thing of it is,
I,
both of them are useful for us because it's like we do want to know what's being spoken about in the corpus as a whole, particularly because if we already pull out the stop words like common articles and we do stemming, which I was, a lot of the things that TF-IDF is there to correct are already corrected because
okay.
it's not getting um, but
So you make it easier for it, basically.
yeah, as far as I know. Now I do need to talk to someone who knows statisticians about this to make sure I'm on steady ground when I say that. But I mean, I've run it both ways, and the difference between just raw weights when you do when you remove stop words in STEM versus when you do like TF-IDF weighting, it's pretty similar. The results you get are pretty similar. There are some interesting deviations, but it's pretty similar, which would suggest, oh, okay, if you're pulling out the stop words, then the difference is pretty negligible between them.
So one question I have about that. So for instance, right, if it sees the word pants showing up everywhere, it will ignore it. But we might be looking for, like, if there's certain kinds of verbs that get at human agency that show up a lot, right? So we might actually be interested precisely in the fact that pants shows up everywhere.
Well, see, that's the thing. So we need both because
Right.
if you think of it both ways, it's like you do want what's recurrent in many places throughout the corpus, right? In
Yeah.
fact, in a sense, if you see something that's super frequent, but only in a couple of documents, that identifies them as outliers, right? I mean,
Right. That's potentially less interesting to us.
right. I mean, like if the raw count pants was in the top three, it'd be like, holy cow, everybody's talking about pants, 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 pants. But
Right.
then, if you wait it and it's like, oh, no, wait, only one document is talking about pants. It mentions it 50 times.
Right.
So, you wouldn't want to say, oh, the corpus is talking about pants because it's not. One document is, right? So they're both valuable for us.
So is this, I mean, just to make sure I'm even getting my key terms right. I mean, is this the kind of thinking about the relationship between frequency and distribution?
Sure. Yes. So
Okay.
like let's take a look. So you can see our studio right now, right?
Yep.
So like this is and I just use a subset. So I just took our first data sample of the A pool, right? So the A pool has over 20,000, but it's broken into about 1,000 chunks. Those were the sample periods, right? Because you remember how I did this. I had sort of a pseudo random. I'd go in, pull 1,000
Right.
of them, wait at least 24 hours, and then do it again. So the first one was 844 of these.
Okay.
And so this, what you're looking at here is, excuse me, the first 10 of the unigrams. So this is just one word. And as I mentioned, I did cut out the stop words, which are, articles and prepositions and such. Sometimes you want to retain those, however.
Yeah. We think we discussed that with Scott, right? The way that prepositions can be useful.
Yeah, and like as we'll look at here in a second, I also did it with bigrams, so two words that are together. And it's quirky because if you do bigrams, sometimes you don't want to pull out stop words because, as Scott pointed out, things like prepositions, right? And also it changes the nature, because bigrams are things that are next to each other. Now, if you pull out stop words, then those things aren't actually next to each other. You know what I mean?
Okay.
Because it's been sliced out first, then the things are next to each other. Like here, let me just pull up.
Huh.
So this, for example, is just a raw count of most frequent bigrams in that same thing, right? So it looks like the most frequent one is you will, and then will be, right? And these look weird because they're stemmed, right? So this is, compensate, compensation, right?
Okay, that makes sense. I was wondering, yeah.
Yeah. But anywho, the thing of it is, there's so many, you can already see the potential variables here in terms of how you're treating this information.
Yeah.
For all intents and purposes, infinite. They may be theoretically infinite. I don't know. But
yeah. So I like that, right? Shop, answer, find, survey. I mean, again, right? Just totally winging it, but some interesting.
Yeah. Well, and see, that's the thing, is what we're going to be doing is kind of firing through a few of these and seeing what pops out. But anyway, since, we're already kind of into this. So these are just raw counts of unigrams and bigrams. If we look at like a weighted one, so let's see, the unigram. So this is with TF-IDF weighting applied to the unigrams. And like, if you look, so survey, it's the same, right? 279 occurrences, and then this is its weighting through TF-IDF, but it's still the top. Now here, study or studies or studying is in second position, whereas here it's in fourth. So there are differences, but it's not crazy, right? Here we've got 2 to 3, brand is down here. It's not like you're getting from the bottom churning back up. And I think this is in part because of things like pulling out stop words. If they were left in and we just did raw counts, I guarantee you articles are going to be the first, the, a, and are going to be, whereas here, this would probably look pretty similar to as it does now, because it would be filtering out those common things.
So quick question. So just so I know I've got this right, the fact that, so let's just assume that there's bigger differences. So survey at just the variable, the unigram is 279, and then once you've done the TF-IDF, it's 181. So my reading of this is that survey shows up in a lot of places, but it's what this lower number suggests is it's less significant than its actual.
Well, let's actually look at that segue, because right now I'm just looking at the top features. Let me do, what is it, text stat, I think. Yeah, so text stats, there's a lot of choices. Can you see this? These choices here? So like if you look at, there's frequency, entropy, lexical diversity, readability, there's all these different operations. If we do frequency, and let's look at that same thing. So, and this is just giving me the whole list, basically, because I did it without telling it how many to provide. So this is the same, right? Survey, minute, hit. You see it's the same thing, and the same counts, 279, 271. But if we move over, it's got the rank, but then it's also got the document frequency. So this is the number of documents where that occurs. 279 occurrences across 188 documents. Does that make sense?
Yes.
So what we could do is look for things like, is there a situation where it's got crazy frequency compared to its document frequency?
Yeah.
Like here, brand, 100.
Brand, yeah.
But 31 documents, right? So
whereas minute, which makes sense because that would be a discussion of how long it takes,
all over
is pretty much that those numbers are very close together.
Yep. So that means it's being distributed across the lot of documents there.
Okay.
Yeah, I'm pretty sure I'm pretty sure what I'm saying to you is not wrong.
Okay. I, listen, that's the nature of this project, and
Yeah.
depending on how wrong we are, um, there's two people watching this right now, and they've not yet chimed in on chat. So
Okay. I'm
that's
glad you.
there's our peer review. We've got two people. That's peer review, and so far no one said anything. So I think we're cool. But yeah,
Uh,
that should be the catchphrase for following Mechanical Turks. We're pretty sure we're not wrong.
um, so, and let me just mute this. Sorry. Yeah. So, I mean, we can look at things like here's an interesting drop off, right down to studies. I mean, look at the difference in frequency of document, right?
Yeah,
So there's an interesting drop off there. Now, it's not like that's bad, right? And this is always the case with text mining stuff. It's like the machine doesn't, it doesn't give you the answer you want, right? Yeah,
right.
tell us what this means, machine, right? It doesn't really do that, but it can identify things like this where we have to look and say, what's going on there? What might be going on there, right? How might we
Right.
understand this?
Yeah.
So that's an example there of
But you
the
can,
kind
I
of
mean, you can see why this is particularly interesting, right? Because I mean, even looking at these, there's certain things. I mean, who knows? It could be nothing, but you look at something like that, and you're like, well, that's it doesn't answer, but it does give you at least some places to start looking.
yeah, it points ideally, it finds patterns or
Right.
we find patterns based on what it shows us.
Yeah.
Um, Anywho, so there are these things we can do, and this is just raw count stuff, right? And we can do this both with the whole data pool, right? Just throw everything into a bag, but then also we can do these individually for each sample. So we could do things like track, sort of longitudinally count stuff that's happening progressively, right? So what happens if at a period of time there are a lot of these things just in terms of counts, and then it shifts to this, and then it shifts to this. You know what I'm saying? So we can actually see over time, are there
Okay.
patterns? You see what I mean?
I
Do it
think so.
do it on the whole pool, but then do it for each period slice. So that
So this list you've got up right now with these counts,
this is just the
this
first period.
yeah. So then what we could do is you could then have the next period and
Yep.
see.
Yep.
Okay, that
And
makes sense.
then you could take all of them and then just throw them into a big bag, right?
Yeah.
And just see, well, over the entire sweep, what's here in terms of counts and weighting, right? And
Yeah.
these are just, and that's a lot of stuff. And this is just the very basic of what to do, because this is just counting, right? So anywho,
And
there's
this is from, you said this is from the first pool. It was like what, 850 hits or so?
844.
844.
Yeah. So like, let me just share my
I
entire.
mean, this is right. This is sort of the when we talked to Scott about the use of. I mean, what's interesting to us is that this, as Scott pointed out, this is actually nowhere near big in terms of big data, right?
No,
This is the methods of data. We're using the sort of big data methods, but our data is not at all big compared to what, just quantitatively not large.
no, we've got about 22,000 documents in this pool, which is not
Yeah,
large.
yeah.
And right now, like,
I mean, it is, but I know what you mean.
yeah. Um, and those operations of just like counting stuff, that's very, very easy and basic, right? So in the interest of time, and you can probably, since I'm sharing my whole screen, you can see this, right? So I've got sort of notes about
Yep.
things we can do, right? Just raw frequencies and then TF-IDF weighting, and there are other weightings we can do, but again, I want to talk to some, this is just a common one. But
Yeah.
we can look at the whole set. We can look at each sample period, right? So we can see if there are patterns there. And then we can also look at it in terms of unigrams, bigrams, maybe even trigrams, 3 words together. And when we get it at those, we'd probably want to do it separately in terms of, what happens when you pull out common stop words, what happens when you don't, because sometimes, prepositions are meaningful or whatever.
Right.
Unigrams, it doesn't matter because that's just one word, but, it would matter if you stemmed versus you don't stem, right? So suddenly STUDI becomes studies, studying, right? you get
Right.
a gerund in there versus,
Oh,
getting,
I see what you mean. Right. It would be getting both, right, nouns and verbs potentially.
yeah, yeah. So that's just sort of raw count stuff. Then we can move on to things like categorization, right? So we've got all these different documents. One thing we could potentially do is put these into categories of, are there different types of hit, right? I have an intuitive sense of what I think this is going to show, like, things that rely upon human sensory data, right? So is there a
Right.
dog in this picture? You know,
Right.
other things that appeal to psychology, right? Fill out this survey. Or when you see this ad, what does it make you feel? Happy,
Yeah.
sad, right? So I have kind of a sense of, yeah, I bet these will break into rough groups, right? So there are ways we can do this through the text. One is like topic models, and topic models are kind of interesting, as their name implies. They take words and they try and pull the topics being discussed out of a big group of words, basically.
Okay.
There are some, now, one thing about them is, to an extent, it's sort of like, the synthesizer in the 1980s, where they are neat. And because of that, they get sort of applied to everything. Is like, let's just take it and throw into a topic model.
Right.
So at this point, it's not like they don't have their use, but it's they've already had their moment where we took everything we could and just threw it against the topic model wall and seen what sticks. So it's not really, I don't want to say it's like passe, but it's like, it's probably not enough just to say, oh, I did it. It's like a word cloud, right?
I see what you mean. Yeah, right. Yeah, yeah, yeah. That analogy makes sense.
It's like, oh, I did one. Here's one.
Yeah.
So there are different ways to do topic models. LDA is a pretty common one. Latent, derelict, crap. I don't remember. Allocation. How did I not know that?
Yeah. Yeah, you got derelict. I mean, that's the tough one there.
Derelict, not derelict, not yeah, not
Oh,
derelict.
derelict. Okay, I didn't see the
Derelict.
spelling. Now I see. Yeah. I like that latent derelict allocation. That sounds like something
It's a
from,
social program. Yeah.
yeah, from some dystopian science fiction novel.
But the idea there is, the topics are within, we are latent or within it, right? And this surfaces them statistically. So let me flop over to this. So I already set this up. Yeah, I can probably just pull it up. I can't remember what I named everything. LDA unigram, probably.
I mean, how does it determine? I guess this is a bigger question, but right, how does it, whatever it is, know latency? I mean, that's a
Yeah. Oh boy. Yes. So as we move through this, those are going to be, yeah, what I'm going to show you has the proviso of, as long as you have absolutely no follow-up questions, I can show you this. But no, those questions haunt this for me.
yeah.
I don't really have sophisticated answers to how precisely what is it doing to make these decisions, right?
Yeah.
And
Which
then,
isn't part what the whole project is about. So this is not tangential to what we're interested in.
no, and it's why we're going to need to talk to people who can answer these questions, right? How are these decisions being made? What happens when we manipulate them? Because here, I can kind of show you. So like, for example, when I'm pulling it into a topic model, you have to do things like identify K, or, the number of topics. So I gave it 5, but I could give it 3 or 10, and the results are different. Because those are the number of categories you want from it.
And it basically it does what it has to do to give you that many.
Exactly. So if I say I want 3, it says, all right, well, I'll break them into 3. If I say I want 20, it says, all right, I'll break them into 20. Now there is a statistical way to kind of.
And it's not, if you ask for 20, it's not going to give you 18 and say these are the only ones that made sense. It's going to give you 20.
Yep.
Yeah.
Yeah. And there is a way of a statistical way of trying to answer, yeah, but how many categories make sense, right? Because otherwise I'm just throwing in numbers and saying, oh yeah, that one looks good, right?
Right.
And partially, yeah, that is what you do, but there is also a statistical ways to do this, like looking for the elbow. So like you can graph when how it's breaking categories, and it shows it's basically a slope, right? And you can kind of see where's the bend in that slope, and that's usually a good choice for that looks like a good number of categories. If it's breaking at 4, sort of like 3, 4, 5 on your X, it's like, okay, well that looks like, because beyond this it's diminishing returns, and before this it's real steep, so it's still the number, because like if you had one category, they'd all be there. If you had two, it's rough.
Okay.
So there's a bend where it becomes, all right, this seems to be sort of in between, too few and too many.
Huh.
But whatever. And then, there are also choices of like the method you use to do this. And there are lots of options there. And again, I can do this, but I really don't have a sense of why I'd pick one rather than the other,
Yeah.
So
Which of the Gibb brothers is that?
it's all of them.
Okay, it's the Gibbs, right? Of course, it's plural. Sorry.
Who are all the Gibbs dead now?
I don't know. Can you run that operation real quick?
We'll see. But anywho, so like let me just really quickly. I don't know if is that the. Yeah, because it's a unigram. Oops, and let me give it an N here. Oh, wait, hold on. Yeah, you don't N. Sorry, I'm confusing a few things. So for example, so I told it to take all that text and break this into 5 categories, just this morning, just to do it.
Okay.
And you can see this, right?
Mm-hmm.
Okay, so it's broken it into these 5 topics, and it's giving me these 10 terms that are characteristic in those topics, right? So topic 1 has task, question, this weird thing, which we'll talk about, right? Because that's one of the things that pops out is there's this whole swath of things that are seemingly written for machines because.
Okay, that's right. That's one of those that yeah, and they were all like back to back to back to back.
Yeah. Complete, take, right? This next one, survey, minute, compensate, complete, answer. So you take these terms and it's like, so these are the characteristic terms for each topic.
Yeah.
What do you think these topics are about?
Yeah.
What do you, I guess that's an honest question. What do you think these topics are about?
I mean, when it first popped up, I was looking at topic 5. I was like, hit, find, audit, list, right? But then there's home and audio. Like home, audio, and second don't seem to fit. But if it was like hit, find, audit, list, transcribe, test.
So it's like audio and transcribe go together, but how's home getting in there, right?
Yeah, and second.
So it may be, so there's a couple things here. One, it's like maybe we haven't set our categories because right now there's just too much stuff jammed in them,
Yeah.
Maybe it looks like 3 is pretty clear. Brand, receipt, shop. It's like, oh, okay.
Yeah.
Maybe you're looking at receipts to transcribe them or something,
Yeah.
But I mean, this is a good example. Sorry, I'm talking too much. So here's something else. There are other ways to do topic models. And like you can, STM means structured topic model. And this, I like this one because it gives you some interesting stuff. So I already ran it.
Okay.
Oh, and let me also give you this before I do that. Because that's the terms from that. What was it? Unigrams? Yeah. This is, because one thing you can do is once you have those topics, if we want to categorize these documents, it's like, okay, well, I've got these big 5 categories, but how do I know which one goes with which, right? You see what I'm saying? Because if we want to break up all those 844 documents, it's like, well, which category does each one go into?
Oh, I see.
You know what I mean? So this actually will do that. It gives you so for each one of these, because each document, man, what time are we at here? Each document has a mixture of topics in it. Each document isn't necessarily only talking about one thing. It's talking about
Right.
multiple things. So there could be multiple topics in each document. That's what a topic model surface is. It's like, you know,
Okay.
most utterances aren't, I'm only talking about one thing. So you, for each document, you can get a probability essentially of stuff that's going on in each one. So in our first thing, let's take a look at it to make this concrete. Well, crap, that one's description isn't there. So our second one here,
Yeah.
input specific variables, you'll be presented an image of a gym, cardio workout, blah, 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 right? So right here, this is it. And it's going into this first category. Now, within that document, there's a probability that one or more of those topics is occurring. So you can actually get a breakdown of in that particular one. It's 50% topic one, 20% topic two, 10%. You see what I'm saying?
Yeah, I see. Yeah.
But this gives you the majority one. So
Right.
it's primarily talking about one, but the others are in there. And this also kind of raises the question of, because we've got a lot of short documents, topic modeling may not be the best choice at all for classification, because it can make more sense with something like a political speech, where we see like, okay, he's talking about this, now he's talking about that, now he's talking about this.
Right.
This is closer to something like tweets, you know, short, probably
Yeah.
mostly talking about one thing, probably.
Yeah.
So this may not be the best classification method, and we'll take a look at that. But anywho, there are other ways to, I'm just going to copy these over. To do models, this is STM. Let me see, how did I name that? STM model. That's probably what I called it.
Yeah, it looks like the one you've got over. Yeah.
I'm just trying to remember. This, I think, is when did I do a bigraph? I don't know. So this is some information you can get from STM. And this, again, I asked it for 5, and you can see now you can't guarantee the categories are in the same order or anything, right?
Okay.
1 isn't necessarily 1 or 2, those are arbitrary. But you can see some things like image, receipt, home, find, list, extract, shop. So that's probability of those terms. But to me, there's some interesting things like fracs here. This is frequency and exclusivity. So it's sort of like this is frequent in this topic and very infrequent in other ones. Frequency and exclusivity.
Yeah.
So receipt, home, list, address.
You can start how it gets a little more recognizable now.
Yeah. Because it's like these aren't really shared. Like if you look at some of these topics, it's probable that some of the words maybe even be shared between them. Do we see that anywhere? Is extract or
there's hit?
Does hit pop up?
And it's the first one under topic 5.
Min and minute. Interesting. Anyway, I'm getting into the weeds here, but this can be useful because this exclusivity measure can be useful because it's things that aren't just probable but are kind of characteristic, right? Separate from these other ones.
I wonder how what did that ad hoc match ACC? Like, how's it making sense of that?
Yeah, we need to ask someone who knows that.
Yeah, I mean, is it taking out the match part? I mean,
hold on.
There's also the point, like, what's it make of the underscore? I mean, now I'm just asking very.
Okay, so here's one. Yeah,
because when you get into the descriptions, it's even. weird. I mean, that just looks, yeah.
Yeah. Yeah. We need someone to explain this. You see, that's the thing. It's like, I'm sure someone can say, there are people for whom this is a very easy question and can point out
Right.
the flaws I've made, or if not flaws, just the choices that are being made here and why this is happening. Um, I don't have an answer for you, but at least we know what questions to ask.
I think, yeah.
Right? Here's what we see. What's going on? So, anywho, so there are different ways to do topic models, but there are also different ways to to categorize these kinds of things. And that's why, like, some of the things I've been looking up deal with tweets, because what we're looking at isn't too far from a tweet.
Yeah, that makes sense to me.
The textual length is pretty similar, and it has certain covariables, right? Like, with tweets, tweets are interesting because they have kind of networks that maybe we don't have, but they do have, like, when was it done? Is this person prolific or not, right? We have
Mhm.
different things like uh, reward, right? So one thing,
Yeah,
we could classify all of these things into groups. We could do even simple stuff like, what's the mean reward? And is that different category to category? Do you get paid
yeah,
more? You know,
that potentially is, I could say that could be really interesting to us, is how does the reward relate to the
the kind of thing.
complexity of the task, or is there actually a way of assessing complexity based on, like, does actually the reward let you know? So let's say they use a word like feel or sense or rank, but are the rewards for all those different? And so is there a way in which this notion of sensation is perceived as more difficult or more complex, so the reward goes up for it?
I know. I mean, there's the potential to find some really neat stuff, right?
Yeah,
Through things like reward or duration, right? Which is it gives you sort of a rough understanding of how long this should take you to do.
right.
Because really, yeah, it's like the allotted time more. That's not precisely what it is, but it is an understanding of how much time a thing should take, which may tap into that notion of difficulty or complexity, right? Is difficult, so
Yeah.
it takes longer. Anywho,
Or it's difficult, but it should be snap. Like, we want your complex instinctual reaction to this.
yeah, yeah. I mean,
So
there's
so
all
is there a
sorts of theories.
correlation between duration, and so there's actually a really high reward, but we don't think it'll take you very long? I don't I Yeah,
There's so much complexity because simple and easy are not synonyms, right?
right.
Um, Easy and difficult are measures of difficulty, whereas simple and complex are measures of complexity. So something could be simple, just put the ball in the hoop, but
Right,
very difficult, right? But I still suck at basketball, right?
right.
Something could be complex and
Or
many
yeah.
steps, but I can do it like that. It's not, they're not synonyms.
Yeah, right, like, dribbling the basketball is simple, but it's actually a complex task of physical coordination or something like that.
Yeah, I mean, I've been thinking about this because sometimes, like, writing tasks, we, um, if you encourage things like minimalism, that doesn't make the task can be very hard, even if it's very straightforward. Or digging
Yeah,
a ditch, digging a ditch. I know what you
yeah,
want, but it's going to be tough, you know?
right. Well, and plus then all those measures are caught up in the moving boundary between what an algorithm can do and what a human can do,
Yeah,
right? So oftentimes it's easy for one and hard for the other, and so this is a simple task for a human,
right.
but an incredibly difficult task. I mean, imagining that when you run these numbers, the operation that's doing it is not breaking a sweat.
Yeah, Yeah,
But but the idea of 20,000 entries seems like a huge number to me that would take forever to make sense of or to even skim through.
yeah.
Anyway, I don't know where I'm going with that one, but
But the takeaway is there's so much stuff we could, it's like a sweater. I mean, there's so much stuff we could pull apart here. What I think this can help us do is identify some of these things. But, and I think we knew this going into it. It's like, it's not like we can take this and just say, well, now we've text mined it. You know what I mean? It's like, there,
right.
there's enough in terms of the small data, the comparatively small data set we have. There's enough there for multiple studies
Yeah.
dealing with all of these different aspects potentially.
Yeah.
So I think what we'll have to do is, run some different operations, see what pops up that we want to engage. And then, in keeping with the project, there may be things that are interesting or correlations or whatever that we don't do. It's just like, well, here's something, but that's for later work or someone else.
Yeah. Yeah, because as we point out in our sort of research statement, right, when we're not aiming for kind of mastery over mechanical Turks, that we're really using
Yeah.
it to do something more inventional. Like, how can we use mechanical Turks to think through this? So in certain sense, we are saying something about M Turks, but we're also using M Turks to. I mean, this is later down the road, right? That we've kind of at least sketched out a kind of three products that would come from this.
Right.
And that third piece would actually really not necessarily be about mechanical Turks. It would be about some question within post-humanism
Yeah.
that we would use mechanical Turks as a, not even as an example, we'd actually use it as a kind of apparatus to,
To get a way in.
yeah. So we're both wanting to say something about mechanical Turks, but we also want to use mechanical Turks to say something about
Other stuff.
not mechanical Turks.
Anywho, so but this is, right now, I don't feel as though I think this is all going to be useful because it's not like, I don't think it's necessarily the case they're just going to go through, all right, now I'm going to do this, now I'm going to do this. It's just we're at an earlier stage where I'm going to fire through some different operations and then find some things that are interesting, but then also ideally not sloppy. Like one thing that terrifies me is like, I might be seeing a correlation because like I'm doing the same thing a couple of times. Like let's say I saw something and then I did another operation. It's like, oh, those two things look like they're correlating. And then someone else points out, yeah, but that's because you just did the same thing essentially twice. You know what I mean?
Yeah.
I'm terrified. It's like I don't really know enough to understand, the what's driving stuff. Whatever.
Right. Like you'd think a correlation you'd found a correlation and an expert would come in and say, no, that's just because you hit this button again.
Yeah, I'm imposing it directly,
Right.
Anywho, so there are other ways to group these kinds of documents together. There's clustering, which I also already did. Let me pull up the notes for that. So this, and this is using, clustering is different than topic models because document clustering doesn't assume that each one is a mixture of topics. So a good example for clustering, I think it's the one that's almost always used, is like if you took chapters out of 4 books and you were walking to the mailroom to make copies and you dropped them all, how would you pick up pages and say, all right, well, this goes with this book and this goes with this book? It's like each page goes with a book. It's not shared, right?
Right.
So clustering is for that kind of situation where it's like, yeah, but each one goes with a thing, right? And this helps us kind of sort out. So like, I think a lot of the examples I look at do precisely that. They take like, 4 public domain books and then throw them into a pot, and then they use statistical measures and clustering to put them back where they go. And then you can actually even check. It's like, is it good? We know where they originated, so we can actually check and see, are all those pages getting thrown back into the right books?
Right.
So I did some clustering, and I was using spherical k-means, which is a method. And this is essentially just a printout of how to assign all 844 of our documents into, again, five. I picked five separate clusters. Now, the thing of it is, I don't really know quite enough to be sophisticated with in terms of how is it making those distinctions? Why is one choice better than another? These are questions I need to ask someone who's familiar with this kind of clustering. But this is another way of grouping documents that is different than topic models because its assumptions are different, right? It's not like there are multiple things being discussed in each one of these. It's like, no, each thing belongs in a binder.
Right. Okay.
There are ways you can fudge this with hard topic models where it makes a clear distinction of, well, each thing only belongs in one, but their conceits are different.
Mm-hmm.
Anywho, yeah, let's move on. So all of this is to get at this notion of, if we can take these documents and put them into groups, then we can start looking at those covariables, right? Like reward, duration, available hits, right? Because sometimes the same job will have a ton of hits, right? Look at that. I mean, that's what, almost 70,000?
Yeah.
But that's one post. So if you take these as separate, then it's giving the ones that have one post parity with the ones that have 50,000.
I see what you mean. Yeah.
So if you want to understand the bulk of the jobs, you've really got to look at the available hits, because this has 50,000 of the same job. This has one. So these shouldn't have parity if you're looking at the bulk of the stuff on there. I even thought about weighting the text by available hits.
Yeah.
So essentially, this would get 50,000 the times of representation.
Oh, I see. So the note. So if we go back, so the list of words and their frequency.
Yeah.
If you weighted it the way you're describing, then say, for instance, study, or the STEM study, would be 40,000 if it appeared in one of these.
Yeah.
Yeah.
You know what I mean? So I mean, it's like you take these words, multiply those by 50,000, right?
And then there's your,
and throw it in the bag with this that has, but here's the caveat. It's because it speaks to this question: what do you mean when you're talking about what's on the service? Because if I'm a Turker and I look at this, I'm not looking at this one 50,000 times. Do you know what I mean?
Right.
I'm looking at job to job to job to job. So they are all equal to me.
Right.
It's just that this person or group needs 50,000 of these done.
So this is one of those where it's up to, basically, that's when we decide whether or not we think the number of available hits is interesting to us or necessary.
It's a question of what is mechanical Turk and for whom, right?
Yeah.
And there isn't an answer to this. It's a subjective question of, is it job to job to job to job, or is it, well, no, this has a ton more pull because it's, if you go on there, this is getting, 50,000 people to respond.
Right.
This is getting one person to respond to it.
Yeah. By the way, why does that one, number 2, the shoe comp, have a warning about possible adult content?
Man, there's so much. I mean, I just sift through these kind of, lightly, and it's like, yeah, there's so much weirdness in this where it's like, yeah, what do we mean by that? I
mean, if they're comparing shoes, it's unclear to me how that. Yeah, I don't even want to speculate.
This could get even weirder because there are qualifications. You'll notice right here, they look like gibberish. In the B pool, they're a lot more readable, but there are qualifications. It's not like anybody can do any job. And
Okay.
some of them do kind of filter out, like you have to be a certain age to see this, or that kind of thing. It's,
Yeah, I saw one of them. There's the password that you have to get.
yeah. I mean, here's the thing. It's like, this minor fragment that we've just got is potentially a lifetime of research. There are so many potential questions of
Right.
just, so it's not like we can do everything. We're just going to have to do a few things here.
I mean, yeah, yeah.
But anywho, and then some other things which I didn't pull up, but like lexical diversity, which is a measurement of, well, word diversity. You can do a text stat that I have to spell it correctly, but that measures lexical diversity and also readability. And you can, it's like Fleischmann, or I mean, there's lots of different ways to measure readability, but potentially, if we group things together, we could even get something like, are hits of this type lexically more diverse, or do they have a higher readability score? I mean, there's all kinds of weeds we could get into.
Yeah.
And then lastly, because we're up against the hour here, there are some other things we can do that I'm just right now calling term connections. So word embedding or word vectors. This is interesting, and this is fairly recent, and now it's word embeddings are sort of perhaps kind of in their moment still of being hot, and there are different ways to do these. Essentially, what this does is, so if you think of things like bigrams or trigrams as words together, and that gives you some sense of context, right? Unlike just sort of pure bag of words where you take each word, everything that's in here, we throw it into a big pretend bag. And it's just like how many of these particular words are in there, right? But there's no sense of context there.
Right.
Now, if you do bigrams and multiple sort of n-grams of different sizes, there is a little bit of context because it's sort of it's with the stuff that it's with, right?
Right.
Now, what if instead of just having it with the word it's next to, or the few words it's with to, what if you could get a sense of statistically how close it is to every word, right? So this word is frequently next to these other words, not just next to it, but within 5 words of it, right? Or
Okay.
within 100 words of it, right? I mean, you could get a statistical measure of its closeness to everything.
Right.
Now,
So it's something like when this word gets used, within 5 words, you're going to find this word, and then that's a way of.
yeah, I mean, you can get sort of a mathematical understanding of how close any particular word is to any other word, right? Because you could take any 2 words and say, okay, well, how far apart do these things appear, sort of.
Yeah.
It's a mathematical understanding of context based on like proximity, but it
Which
doesn't need
is
to be next to it. It's just sort of in the same area.
which is kind of interesting too, because that area is then. I mean, right? The Turing instinct in me, right? Sort of his critique of context. Like, I don't know what context is, but it's roughly the size of a pumpkin, right? Because when
Yeah.
everybody describes and his critique is that we imagine context as a kind of container in which things are happening, and he's much more interested in, right, the context is actually made by the context is an effect of, right, it's so what's interesting about this, the thing you're describing, is it doesn't imagine context as this pre-existing container, but the context is a function of the distance between, or the relation between these words, right? The words make their own, the words aren't in a context, the words generate their own context by virtue of the relationship between the other words.
Well, and to undo that, because the method to do this is you essentially identify a window of whatever length you want, and then that window kind of scans along, and it takes those words and it connects them to everything that's within the window. So if you had a sentence, the quick brown fox jumped over the lazy dog, you take the, and then you distribute it to each one, right? The quick, the brown, the fox,
yeah,
you know what I'm saying? So
yeah.
it does this, right? And then it moves the window, and then it does that again with everything. So you set the window and it does, and you can see how computationally expensive this would be, because instead of just taking each word or each two words, it's got to do this weird thing for every, you know, as it slides along. It does that for every word, right?
And then it stitches it back together again.
Well, it gives you probability. Let me see, I can probably pull it up. Oh, that's the functions. Let's see. Yeah, so that's that. Okay. Yeah, so like it gives you a value of each one. And so let me show you something we can do with it. Where did I? Yeah, hold on just one second, because I've completely forgotten where I put all this stuff.
I'll vamp.
Yeah, you do that.
So
I don't know, what questions are brewing with you?
oh, I don't know. I mean, mostly this is just
Here we go.
fascinating. I mean, in many ways, it's, you know, what questions can we ask, and what, I mean, it seems to also be, I mean, this is probably why we need to talk to somebody, is that the questions we might ask are going to be tied to the kinds of operations that we feel comfortable running.
All right, oh, let me share this. Share screen. All right, so let me see this. Yeah, I don't want the. Oops, here we go. Okay, so for example, I picked out a word from our corpus object just because that was an interesting one, right? But we could put in other stuff that pops out. Like what's something that came up that was common?
Like survey or something like that.
Yeah, unless that got stemmed. Let's see. Oh, there you go. So this gives you a statistical measure of its similar stuff, right? So survey is connected to about, it frequently has itself when you do this. Doesn't that's not surprising. So it's connected to things like about this 7. I should have pulled out numbers, huh? Minutes.
That makes sense. Huh.
Workplace, right? So word vectors allow you to do interesting things because it's essentially kind of a mathematical breakdown of some notion of semantics. I mean, the sort of the common example they use is you can run it through a text, and then you can do things like actual math with it. The typical example is it'll allow you to do king minus man, and it'll return to you queen. It somehow statistically knows that a queen is like a king, but not a man, right?
Wow.
It has to have the text to do that, but that's the idea, is you can actually run mathematical operations on things, on textual things, right? And we can do that right now. In fact, although I didn't prepare any because I was just scrambling through this, but it would allow us to do things like, you know, some job minus human equals what, you know?
Right.
Yeah,
Right.
I mean, you can do that kind of stuff.
This minus this equals human.
Well, and curiously, I mean,
I mean, yeah, that would be like the ideal. We can just do that, and that's.
Well, I'm not sure human comes up.
Oh, right. That's true.
It does. Anonymous group, that makes sense, right?
Wuhan.
What's that?
The fourth one, Wuhan.
Yeah, I'd be interested to see, and we could run a keywords in context and see where that's appearing. Or I guess we could probably just do it here. That's interesting. Human computer interaction. That's where it's getting human.
Yeah.
That also seems like a pretty, I mean, that was only one. Well, whatever. I'm running this on such a small thing. Every occurrence is meaningful because I'm running this on a really small slice in order to make this doable. Otherwise, it can take quite a while to run some of these things. Anywho. And then there are also textual networks, and yeah, we'll wrap things up here. But these are things that, as the name implies, they're like network diagrams, but for text. So its connection to other terms and what branches off that. And these actually could be really useful for certain key terms because it shows you visually how it connects to other concepts or other terms. So anywho, we're at the hour mark here. The takeaway here is this. There's lots of stuff we can do. And so what I think our next step is, and I don't think I mentioned this, I'm talking to some folks here in our data science and in our digital humanities units here who work with text mining. Most of them don't work with R, but we can go over, I can show them, here's the data, right?
Right.
I can talk about, because a lot of these things are just common text mining operations. How you do them is specific to R, but
okay. But
yeah, all this stuff. I mean, you do topic modeling in a million different ways. You could do this through visual, through what you see, what you get programs, statistical programs. You don't need to run R code or Python. You can do that a million different ways. So I'm going to, sort of walk through some of the stuff I'm doing and have them, check what we want to do. And then I can kind of figure out how to do it in R. But that I think is going to be the next step is, talking with people who do this, particularly the data science people who do text mining and can point out, oh, you're totally wrong about this, and what you think is going on here is wrong. I mean, I willingly admit my ignorance about this. I mean, it's one of those things where I don't have a good base. It's like I know how to do certain things because I had to do those certain things. So in certain ways, I've got a little bit of depth, but I have just not a good breadth. I mean, my stats is super weak. Because I just had to learn targeted things. It's like, I need to do this. And so I figured out how to do it. But that's so shaky because it's like, well, what if you need to make some changes, or what's this versus this? It's like, I don't know.
Right.
So I need to talk to some people with that kind of knowledge. That's the next step. And then we haven't looked at the B pool because I think, the B pool is so much smaller because it's I think it's 100 a pop. I think it's got 1,000, right? I can't even remember. I should pull it up. But it has richer metadata. So the question will be, like, I don't think we're going to be doing these sort of larger things with the B pool at all. I think what the B pool is going to be good for are these kind of covariable things. And so it could be that we just take the A pool and do a lot of this stuff that benefits from a larger pool. And then we do this kind of categorization and covariable stuff maybe on the B pool. I don't know yet, but it could be that the different pools, we do different stuff. And right now I am treating them separately. It's not like I'm folding in the textual content from the B pool into the A pool. Right now they're completely separate. And when I sampled, they were at different times. It's not like I did one and then the other back to back.
Yeah, we wouldn't want to collapse them potentially for that reason.
Yeah. So the question will be kind of, sort of, because, the B pool doesn't lend itself to just big stuff. It lends itself to more fine-grained stuff like, because that's the only place where we get things like Turker feedback, right? Do you feel this is fair? That's the only place you get that. So, I mean, I can envision a situation where either we do categorization with both pools, because then we both pools together, because then we could incorporate that more sophisticated, but well, we could do it for the purposes of classification, then classify everything in the B pool according to that schema. And then we can look at those covariables. But I mean, at this juncture, I don't really know. And I've just sort of been working with a little bit of the A pool right now. It's just something to kind of keep on our radar. What's going to be useful for the two separate pools?
Yeah, and I think you're right that even to know the question of what's useful or reasonable is probably something that we'll need guidance on.
Yeah, let me see. I think it was maybe, I think it's 2,000 because I think it was 20 samples of about 1,000 each. Anyway. All right, anywho. Okay, so that's kind of where things are now with this. You know, our semester's getting close to wrapped up.
Yeah.
So I'm going to be spending some time on this, just running through the operations. So I'm going to be talking to some folks here. You mentioned you might have a line on some folks who could potentially answer these questions too at your.
Yeah, we've got a colleague in the English department. He's a literature person, and then a couple of grad students did a text mining initiative. And so yeah, I was gonna contact them here in a little bit to see if they might be either both of them or maybe one of them as a representative for the group.
So I mean, if you want to do that, all that data is.
The thing I thought would be particularly interesting, I think we talked about this on air, is that their project was they were interested in identifying forgeries.
Philology.
So I thought, so.
That is interesting because it sort of, it taps in this notion of authenticity. Is that what you're?
Yeah. That notion of sort of, yeah, it gets around. I mean, they're kind of interested in questions of period. So one of the issues they had to solve early on, like what as I think we're discovering, is that as you start doing this, your project has to also become about other things. So before they could really get into the question of forgery, right? Is this thing written like it's from the Middle Ages, actually from the early modern period? Yeah. Right. Before they could do that, they had to know if the machine could at all differentiate between the medieval period and the early modern period. Right. If it can't tell the difference, there's no way it's going to be able to spot a forgery, because it doesn't know that to ascertain whether one thing is faking being another, you have to be able to distinguish those two things.
Yeah, it's an interesting notion also of context, right? Because you're essentially looking at stuff in a context. So it has to understand, it has to have some knowledge of what that, although we wouldn't call it knowledge usually. It has to somehow be able to correlate to make it, does this fit in its context? It has to there's no other word. It has to know something about context. This is like a Kevin Kelly kind of problem, right? He did what technology wants, right?
Yeah.
Because he uses that language intentionally because it's provocative, right? I mean, here's kind of the same thing where it's like the machine has to know what the medieval period is, right? Even
right.
Yeah, but it doesn't know. It just is, stitching words together. It's like, yeah, but what other term do we have for that? It has to know.
Yeah. I mean, I think I think the word they used, because I remember I once even had a conversation about, right, they gave a presentation and they had used the word reading, and he goes, I wouldn't really say that it's reading. And I kind of asked the question, I said, I think I would say that it's reading.
What's the difference?
Right. But so I think they ended up using a word like, instead of know, they would use a word like parse, right? It's able to parse the difference, but yeah, but I mean, I'm also, that was my own kind of thing. Like, no, it knows. That doesn't mean it knows like we do. It knows differently, right?
Yeah.
The human is not the gold standard for knowing. I can say that it knows. That doesn't mean I think it's doing what I'm doing, but
yeah. I
who
think
put
that's
me in charge of
part of Kelly's point is, the sunflower wants the sun. It doesn't mean it's
Yeah.
the same sort of want, but
Right.
it wants the sun. It turns toward the sun, right? So
Yeah.
he's using that in part to sort of force us to examine, if it's not a desire, what is it? What sort of, grammar do
Yeah.
we have to?
Well, and that what's interesting, and neither here nor there because we're wrapping up. But John Mucklebauer has a recent piece in a edited collection. But his new model for rhetoric, as he calls it, heliotropic.
Hmm,
Right, the idea that we can understand rhetoric. If we want to have an expansive notion of rhetoric, it's this idea of turning towards the sun, but it's this instinctual, habitual, but it's a more expansive notion of what rhetoric is, a kind of turning towards something.
yeah,
And then he uses the notion of the plant turning towards the sun as his kind of model for that. Anyway,
yeah. Well, so that'll be, I guess, the next step is, over the break here to shake some of these things out, and then I can start running on the actual pool, because right now, I'm just doing thin slices so that I can actually computationally do it. Because if I, try to bang my way through the whole pool, each time you run some of these, like, word vector stuff can be computationally intensive. It can take a long time. Now, luckily, our pool isn't that huge, but it can take half an hour to run some of these things with the real pool. So I'm just doing a narrow slice just to make sure that everything actually works. It spits something out on the end.
yeah.
Um, is there anything else we need to keep on the horizon in terms of? I think
I
this.
don't. I don't. I think we need to kind of. I think the plan for now is you talk to people who might be able to offer us expertise, and then and then I'll contact these people as kind of um, people who've done something vaguely similar that might just have some insights. In part because I think what I just talked myself into thinking about what's interesting about their project are the other things they had to get it to do before they could get it to do the thing they wanted it to do.
Hmm,
Right, the sort of problems that other sorts of operations or even machine learning things they had to deal with first. That what did they have to teach it to do so that they could do the other thing they wanted to do.
yeah. Yeah, and like the word embedding stuff like Glove and Doctivec, those do use that, they do use machine learning in order to it's one of the reasons why it's expensive, or computationally expensive, because it does use, machine learning. The one I was using right there actually as much as I can follow it, it looks like it's just using algebra. It looks like it's just using linear algebra, but I don't I don't know enough to really say
No,
what's going on in this. There are parts of this when it's like I'm not exactly sure what you're doing here.
no,
Anyway,
I had a student in my class who's in math, and he had one of those really, fancy calculators. I didn't even know what half the buttons on it were, much less,
yeah.
So
Oh, and if we talk to folks, and it would be useful to have them as guests, we can of course.
yeah, I was thinking of yeah. If can you come talk to me about this? Also, here's the link to the Zoom because
Yeah,
we want to record it.
this is our first time piping Zoom to YouTube. This seems
It's
like it's just.
I have YouTube up and running, and it's up, and there's some people who've been. There were three people, now there's two. We lost somebody at some point.
Yeah, I mean, there'll be some things to shake out with, because like I had a pre-set up link, and I didn't pipe to that, so I'll have to
Yeah,
figure that
and I'm
out.
assuming we didn't lose them from some technical glitch. I assume it was the content of the video that did it.
Probably just the visuals. All right. Well, that's it.
Oh, point of order, by the way. I have an issue with you that I want to raise publicly. On your editing of the last episode, in the live version, you ended it by complimenting my sweater in a really snarky way. And I really enjoyed the zing.
I
I then
know.
told my wife about the zing, who hates that sweater, and I went to go show her the zing, and it was gone.
I know.
Uh,
I
and so I
wanted to
feel
keep
like
that
I
too.
think you're putting out compromised versions of these things up on the internet.
Yeah, you know what happened? That broke my heart too. What happened is when YouTube has very rudimentary editing tools,
Yeah.
and when I snipped I think the beginning, it for whatever reason it just sort of reorganized stuff,
Mm.
and so that is gone. I mean, there is no original. That that is,
It
it's as though it
was
never existed.
I mean, if you ever wanted to just teach, some basic introduction to Kairos, it was a good zing, well delivered as you hit I mean, it was the equivalent
Right
of like
before
the
it
sign. Yeah, right as you angrily hang up the phone call, it was like, oh yeah, oh nice sweater, click. It was
Yeah. That
yeah,
breaks my heart too, but that's the promise and peril of working with the machine.
yeah. Okay.
All right. Hopefully this one will turn out better.
I hope so.
All right. Well, I'll talk to you later.
Okay. Bye.
Yeah.